right, hi everybody. So last week we spent the whole week reviewing all of the fraction concepts that we had covered so far. We talked about fractions as a whole, fractions as part of a set, and we spent a lot of time reviewing fractions on a number line. And the reason that we spent all that time reviewing is because now we're going to start getting into working with fractions. Before, we were kind of just trying to figure out, what is this fraction? How can I make this fraction? But now we're going to kind of get into playing around with them a little and using them a little bit more. So I wanted to be sure that you really understood them before we got into this next stuff. So today we are on the lesson about fractions as one whole. Now here's the thing. Lots of kids get a little bit confused on this lesson, and that's okay. It's kind of tricky to wrap your brain around, but once you get it, it will make sense. So just kind of stay with me, and if you don't understand, that is okay. You can always reach out for more help from your teacher. Okay, so you need your workbook. We're on page 607, and if you don't have it yet, go ahead and pause the video, grab your workbook, and then come back. Okay, so like I said, today we're going to talk about fractions as one whole. So whole numbers can be written as fractions, right? That's what we've talked about this whole entire time. A fraction is when you cut something up into smaller pieces or you look at the pieces of it. When the numerator is the same as the denominator, so when your top and bottom number are the same, the fraction equals 1, okay? So we're going to kind of look at two different ways to talk about fractions as one whole. We're going to look at fraction as a whole and fraction as a set. So first, let's look at the fraction as a whole. Okay, it says, example number 1. There are 4 panes of glass in one window of Landon's classroom. Each pane of glass is 1/4 of the whole window. So how many fourths will equal one whole? Okay, so here's Landon's window. How many windows are there? Just one. We have one whole window. How many parts was that window cut into? 1, 2, 3, 4. So one window has 4 parts, okay? So this part is 1/4. This part is 1/4. This is 1/4, and this is 1/4, okay? If we drew that on a number line, that would be one pane. There's another, and there's another, okay? So the window is divided into fourths. So how many parts are there? There's 4, and it's divided into fourths. So how many fourths equal one whole? 4. It takes 4 of those panes to make a one whole window, okay? So 4/4 equals one whole window. And if we write that fraction, I would write 4/4, okay? My top number tells me how many parts am I talking about? Well, I'm talking about the whole thing, and there's 4, okay? And then how many parts was it broken into? 4, okay? So I read that number as 4/4, okay? If we wanted to use a number line, it says place a point on the number line to graph this fraction. The model shows that 4/4 and 1 share the same point and have the same size. Okay, so if I was going to do a number line, I would draw it. I would cut it into fourths. And remember how when we were talking about number lines, we always started with 0 and then ended at 1? Does it make more sense now why we did that? Because 1/4, 2/4, 3/4, 4/4 is the same thing as 1, okay? Because that means all 4 parts equal one window, okay? So 4/4 is one whole, or if I wanted to write that as a fraction, 4/4, okay? Now, this is going to hold true with any fraction as a whole, okay? So if I had this shape, okay, and I'm talking about this part, this part and this part, my fraction would be 3/3 because there are 3 parts and I'm looking at all 3 of them. How much of the triangle did I shade? I shaded, whoops. There we go. 1 whole triangle. What if I have, actually no, I don't want to draw that one. Okay, I have a rectangle, it's divided into 8ths. So my denominator would be 8. And then how many parts would I talk about? All 8 of them. Okay, so 8/8 equals 1 whole rectangle being shaded. Okay, so the important thing to take away from this is anytime that your numerator and your denominator are the same, it equals 1. Okay, that means that you have 1 whole shape. It doesn't matter if it's 2 halves, like a 2/2, or if it's 100 100ths, a 100 over 100. It still equals 1. Okay? Now, I don't want you thinking that's too easy. So let's flip the page. Okay, and let's look at our next example, example 2, okay? So it says, how many wholes are in 3/1? Uh-oh. We just talked about what to do if it said 1/1, that would equal 1. Or if it said 3/3, that would equal 1. But 3/1, so this is what it will look like if you have fractions as part of a set. Okay, remember we talked about the difference in what a whole is and what a set is? So this is how we write for a set, okay? So think, the top number or our numerator is telling me how many parts. There's 3 parts, okay? How many groups are they partitioned into? Just 1. It is 1 whole set, okay? So if you think that you have 3 counters, okay? I have 3 counters for my numerator, because that's how many there are. And then how many groups of the counters do I have? It's just 1 group, okay? Now, here is the part where it gets a little bit tricky, okay? What does 3/1 mean? What is that as a whole number? So if I want to write that not as a fraction, but as a whole number, what is it? Well, I just need to count how many whole shapes do I have? 1, 2, 3. Okay? So when we talk about fractions as part of a set and a whole number, I just look at how many are there. So 3/1 would be my fraction because I have 3 parts in just 1 set. And if I think of that as a whole number, it would be 3. So let's practice a couple of those. I know that can be tricky. Okay, there we go. So what if I have, okay, there's my set, okay? So first of all, let's figure out our numerator. How many shapes do I have? I have 5 whole circles, right? So my numerator would be 5. How many sets do I have? It's just 1 set. So 5/1 equals what? Right, 5, because that's how many counters I have, okay? Honestly, it's so easy that it's tricky, because there's a lot of thought that goes into understanding this, okay? But actually practicing it, don't make it harder than it needs to be. Let's try one more. All right. Okay, there's my set. How many shapes are in my set? 1, 2, 3, 4, 5, 6. How many sets do I have? Yeah, just one. What is 6 over 1 as a whole number? How many shapes do I have? 6. Okay, so 6 over 1 equals 6. All right, so the important thing that I want you to remember from this lesson is if my numerator and my denominator are the same, then it equals 1. Okay, that means that I have one whole shape shaded. See, the whole rectangle is shaded. If my numerator is a big number and my denominator is 1, that means that I have a set with 5 items in it, okay? And there's only one set. And if I write that as a whole number, it would be 5. All right, so I know this can be a little tricky, but you're still gonna go ahead and try your practice and then check it in the video with me.